Welcome, my friends. The standard form equation of a circle is x minus h squared plus y minus k squared is equal to r squared. The circle is centered at the point h, k and has a radius of r. Let's look at an example. Here we have a circle that appears to be centered at the point 2, 3. The distance from the center to the edge of the circle is 5 units, which means the radius must be 5. Looking at our equation for a circle, this must mean that h equals 2 and k equals 3, and that r is equal to 5. Plugging into the formula, we find that the equation of this circle is x minus 2 squared plus y minus 3 squared is equal to 5 squared. But 5 squared is equal to 25, so we have 25 on the right-hand side of our equation. Let's say we are given the equation of a circle, x minus 1 squared plus y plus 4 squared is equal to 9, and we are asked to graph it. The first step will be to identify the center and radius. The center is at the point h, k. But remember that h and k are subtracted in the equation. So h and k have the opposite signs of what you see in the equation. We have h is equal to positive 1 and k is equal to negative 4. The value to the right of the equal to sign is usually the radius squared. So that means r is equal to the square root of 9, which is equal to 3. We have a circle centered at 1, negative 4 with a radius of 3. We can plot the center at the point 1, negative 4, and then move 3 units up, down, left, and right to find additional points on the circle, since 3 is the radius. If we connect the dots in the pattern of a circle, we will have graphed our equation. We can see that the radius is 3, as the distance from the center to any point on the circle is equal to 3. Let's try a few different types of examples involving circles. Say we want to write the equation of a circle with a center of negative 8, 2 and a diameter of 12. We know that h and k are related to the center of the circle, and we have h is equal to negative 8 and k is equal to positive 2. The diameter is just the length of the line that crosses through the center of the circle, and is twice the radius. So that means that the radius must be half of 12, which is 6. Putting everything together, we have x minus negative 8 squared plus y minus 2 squared is equal to 6 squared. Simplifying, x minus negative 8 is just x plus 8, and 6 squared is 36. So the equation is x plus 8 squared plus y minus 2 squared is equal to 36. This is our final answer. Here's what that circle would look like. You can see that the radius is 6, which is half of the diameter of 12, and that the circle is centered at negative 8, 2. Let's try another one. Say we want to write the equation of the circle that has a center of negative 4, 5 and passes through the point 6, negative 5. We have the center of negative 4, 5, which means that h is equal to negative 4 and k is equal to positive 5. But we still need to find the radius. The distance from the center of a circle to any point on the circle is the radius. So we need to find the distance from the point negative 4, 5 to the point 6, negative 5. We can use the distance formula to find the radius, which is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Letting the center of the circle represent point number 1 and the point on the circle represent point 2, we have d is equal to the square root of 6 minus negative 4 squared plus negative 5 minus 5 squared. This simplifies to the square root of 10 squared plus negative 10 squared, which is the square root of 100 plus 100, or the square root of 200, which is the radius. We have all the pieces we need to plug into the equation of the circle. X minus h squared plus y minus k squared is equal to r squared. We have x minus negative 4 squared plus y minus 5 squared is equal to the square root of 200 squared. This can be simplified to x plus 4 squared plus y minus 5 squared is equal to 200, which is our final answer. Here's the graph of the circle, which has the center at -4, 5, and has the point 6, -5. We can see the radius here, which is equal to the square root of 200. Let's look at one more problem where we need to graph the circle, but there's a little bit of a twist. The equation here is not in standard form. We have x squared plus y squared minus 4x plus 2y minus 20 is equal to 0. We need this equation to be in the form x minus h squared plus y minus k squared is equal to r squared in order to graph the equation. The first step is to move the 20 to the other side of the equation. Now let's group our x terms together and group our y terms together. All I have done is move the x squared and -4x terms to be next to each other, and move the y squared and 2y terms to be next to each other as well. We need to complete the square, both for x and for y, in order to match the standard form equation of a circle. Remember that, in order to complete the square, we need to add half of the coefficient on the term to the first power squared. And here, since we are completing the square twice, we need to do it both for x and y. For x, half of -4 is -2. -2 squared is 4, so that means we must add 4 to both sides of our equation. Looking at y, half of 2 is 1. 1 squared is 1, so we need to add 1 to both sides of the equation. We are left with x squared minus 4x plus 4 plus y squared plus 2y plus 1 is all equal to 25. I've grouped what will become our perfect squares together in parentheses. Now these should each factor as perfect squares, where the constant is half of the coefficient on the variable to the first power. For the x's, we have x minus 2 squared, as half of -4 is -2. If you want to check it, you could FOIL it out. X minus 2 squared will equal x squared minus 4x plus 4. For the y's, 1/2 of 2 is equal to 1, so we have y plus 1 squared. Altogether, we have x minus 2 squared plus y plus 1 squared is equal to 25, which is the equation of our circle. From here, we can easily identify the center of the circle, which is at the point 2, -1, and the radius, which is the square root of our constant on the right-hand side, which is 5. We can plot the center of 2, -1 onto the graph, and then move 5 units in each direction to find points on the circle. We can connect the dots in the pattern of a circle to complete our graph. Alright, my friends, that completes our video relating to graphing circles.